wish you a very happy World Kindness Day today. I always think these things are kind of funny, right? Because I feel like you should be kind all of the time, not just on World Kindness Day, but maybe be extra kind today. Reach out a little bit more. Be nice to everyone. It's a thing, right? Be kind all the time. My kindness to you today is that I'm going to give you an opportunity to show me what you know, okay? More than one, so that's great. We're going to do a warm-up problem to just get our brains back in this. Hopefully you have spent some time between Friday and today working on free body diagrams and F-net equations. If not, let's get our brains there again. So I said to you on Monday and Tuesday that today your quiz is going to look something like this. Okay, like problems like this, there'll be 2 of them. Okay, so we're going to do that in just a few moments. But before that, we're going to do a practice. Then we're going to do our check-in, and then we're going to start doing some finals preparation. Okay? So what I need you to do right now is to get your warm-up sheet out or get a piece of paper out. Everybody should do this. Strongly recommend that you work on this problem right here. Okay? So here we go. I even gave you the information today. You're welcome. So Sweetums, if you don't know him, he's a big Muppet. He's pulling his sled along a rough horizontal surface. Think like snowy, but not slick and smooth, okay? Using a rope that's pulled at an angle of theta above the horizontal. It says that the box moves at a constant speed. So I don't have an extra sheet like this to print out for you, but you can just write this on a piece of paper, write this on your warm-up sheet, wherever it goes for you. I'm going to give you a couple minutes to try it, to talk to your table mates, and then we'll discuss it, okay? This is your opportunity to solidify that information before we do our check-in so that I can see where you are, you in and of yourselves, okay? So go ahead and take a moment to do that, and then we will discuss. You can absolutely talk to each other. You can absolutely look at your notes. This is the time to do that so that you're ready to go for the next one. So let's talk it through here. What kind of forces are acting on the sled? I should ask, what is the system? The system is the sled. The thing we're going to draw a picture of is the sled, right? Bella, what you got, my friend?
Well, actually, I have a question.
Yeah, go for it.
So our group was talking about using tension or applied force.
Uh-huh.
And so more or less it was, since like there is a rope, but he's the one pulling the rope, would that be tension or applied force?
So I would say technically I would call it a tension force because there's a rope. But honestly, if you had everything else but you called it an applied force, as long as it was clear that that's what it was, I would call that okay too. Yes. Does that make sense?
I mean,
Yeah.
It was just confusing.
Yep. Either one is fine. That one, tension and applied force, like I can kind of see, especially in this case, that you could call it either one, and I think either one is fine. Yeah. All right, so can we add that tension force?
Yeah.
Where does that tension force exist?
At
At an angle. So like any angle?
I mean, it doesn't really tell you which way it goes left or right.
It doesn't. And so you get to pick because you're the one that gets to talk. So we're going to go to the right. Okay. And so does the force go directly to the right? Or does it go down or up from the right? It goes up. How do you know that it's up? Oh. There's something in there that tells us that it's up. What is it? Can you help me out? What'd you say, Corey? Yeah. It says above the horizontal. Bam. So there's going to be a force like this. I'm going to call that force of the rope on the sled. I'm going to call that a tension force. But again, you can call it whatever you want. I mean, by that I mean either tension or applied. Either one's good. All right, what else you got, friends? Raise your hand if you can tell me another force, something else acting on the sled. I know you know it. Because I saw you talking about it. I can start calling on people if you want. There are a couple easy ones. You already told me once, so I'm not going to pick on you again. Go for it. Gravity. Where does gravity pull or push? Down, straight down towards the center of the earth. And so when I draw that force, it's going to go straight down. And remember that every force is an interaction between how many objects? 2. So when I label it, I'm going to say the force of the what on the sled? The earth. and then in parentheses, FG. Friends, if on this check-in you just write FG, you will not get a 9. I'm going to let you know that now. Fair warning, okay? In order to get full points, to show me I can draw a free body diagram of an object, that's what the standard says, or something like that, you need to say earth on sled. If you don't have that FG, I honestly don't care, but the earth on sled is necessary. Does that make sense? Everybody's heard that. Force is an interaction between two objects, always, always. All right. Are there other forces acting in this story, or is it just those two? There's more, Bella says, but I'm not going to call on her because she already told me something. So somebody else has got to volunteer.
Can I volunteer someone?
No, I feel like that's awkward. You can encourage someone to volunteer.
Okay. Abby.
The longer you take on this, the less time you have to do things later. Go ahead, Melissa. What you got? FN goes straight up? Yeah. So that one's going to go straight up in the air this way. And that's really the force of what on the sled? The surface? Yeah. Or it could be, maybe it does just say surface. Yeah. But it could be like the ground or the road or whatever. It doesn't matter. Surface on the sled. That is an FN. Cool. Thank you. Are there any other forces acting? Bella says yes. She's pretty adamant about this. Mara, you're saying yes too? Can you tell me what else might be acting? Force of friction. How do you know that the force of friction is acting? Oh, it's moving at a constant speed. Do you guys see that? Constant speed. That means that it's not what? Accelerating. So I'm gonna try and jump into your brain there for a second. Is that okay? She's like, wait, I don't know if I'm comfortable with that. Like, not literally, just figuratively. In the X direction, we are not accelerating. So this is gonna be a no. You with me there? No, we are not accelerating in the X direction. If we're not accelerating in the X direction, what does F net have to be in the X direction? It has to be 0. And if I look to see what's acting in the X, part of FT is acting in the X, right? So that means that this, I think, is how you were kind of reasoning through this, that there must be something pulling the other way, because you got to have two forces adding up to be 0. You can't have just one force add up to be 0. Not possible, right? Some number that's not 0 added to nothing doesn't give you 0. You can't do it. So there's got to be a frictional force. Where does it go? Where does it pull or push? Right? It's always parallel to the surface. So this is the force of the surface. On the sled, this one's parallel. This is the force of friction. Okay. Sweet. Are there any other forces acting on the sled? I don't think there are any other things pulling or pushing on the sled. So does that mean we can go ahead and start writing our F-net equations? Sure. So let's do the X first, because we already kind of started it. It's not accelerating because it's moving at a constant speed. F-net is 0. We have to add up all the forces acting in the X direction. What's pulling or pushing in the X direction, friends? Go for it. FF is pulling or pushing in the X direction. Positive or negative? What do you think? Negative, it's going backwards, right? So if we kind of write out our positive and negative situation here, this is positive, I would say so. Anything else acting in the X direction? FT? Is it the entire FT that's acting in the X direction? Just FTX, right? So I can break this into two pieces, and one of them goes this way. This is FT in the X direction. There's my angle theta. It is just FTX. Part of the FT is in the X direction. Part of it's in the Y direction. I would call this FTY, right? This part and this part have to be the same. Does that make sense? If you want to mark that, you totally could. You could mark that those are the same. That's helpful so that we know that they're the same. Okay? And you can take it one step further and say not only is it FTX, but it's really FT times what? The cosine of theta. Okay? For the purposes of today's assessment, I will accept either one of these lines, okay? I will let you know that next week, when I see you and we do this again and we add numbers, then you'll have to be comfortable doing this. So it's a good thing to get started getting in your brain. But again, either one of these is fine for today, okay? That's the X part. Let's do the Y. Is the sled accelerating in the Y direction? It is not. It is not. Let's figure out what it's doing. Well, we need to add stuff up. What's acting in the Y direction? What'd you say? Gracie, did you say something?
No.
Oh, I thought I heard a voice from over here. Was it somebody back there? What'd you say?
Gravity.
Gravity. The force of gravity. Is that one positive or negative? Negative. So we're going to put a negative sign in front of it to make sure that we know that it's negative. What else is acting? In the Y direction. Anything else? I haven't heard from anybody over on this side of the room. So let's share the fun with the left-hand side of the room over here. FN. Absolutely. Is that one positive or negative? That one is positive. Anything else acting in the Y direction? Yeah. Awesome. So we've got FTY, or she said FT times the sine of theta. Is that one positive or negative? Is it positive? Because it's going up? And what do these three things have to add up to? Zero. Quick question just to make sure that we're all on the same page. If I just set a frog on a table, Fn and Fg are equal. Are Fn and Fg equal in this case?
No,
Why not?
because you have FTY, so we can't be
Right, because FTY plus Fn has to equal Fg, right? So the normal force, the force of this surface pushing up on the sled, is it bigger or smaller than it would be if it was just sitting still? It is smaller. It is smaller because the rope is also pulling up on the sled. Okay. Questions about this before we move on? Got it? Feeling good? If that's the case, you can take all you need is a pencil today. You don't even need a calculator, okay? I will hand out equation sheets just in case you feel like you need them. It's nicer to have things than not have it if you're getting stuck. Go ahead and move to your assessment seats and we will assess this, friends.